So, welcome everybody. I think this is the last talk here, and there will be some lightning talks and closing keynotes. So, towards the end, everyone is a bit tired, I can imagine. Cansu and I will be talking about building scalable Kubernetes governance using Kyverno and Cell. Together, we had some online talks in the past, like GitOpsCon, a couple of GitOpsCons, and this was the first time we'd be on the stage together, but unfortunately, still we half made it. She got sick after some travel, but she joined online, so we'll try to do it together. Yeah, my name is Koray. I work for Kubernetes as a consultant, and I'm active on CNCF side, a CNCF ambassador, also a platform engineering ambassador. I'm organizer for KCD and DevOps Days Istanbul as well. I also do contributions to Kubernetes project around K8s infra and SIG architecture with conformance testing. Yeah, that's pretty much it. So more working on Kubernetes and the stuff around it. So, yes. Cansu.
So, hello everybody. I hope you can hear me well. I'm so sorry that I couldn't be there. Everybody knows that Helsinki is one of my favorite cities. I've been there many times, winter and summer, and I just love the city. And I feel terrible that I couldn't make it, but hopefully next time. Next time I'll be there. And thanks Koray and the organization to let me at least be there spiritually. So my name is Cansu. I'm a platform architect at Red Hat. So all my career, what I did is working with organizations to build the platforms that fit for their developer needs, but also build the platforms that are, useful, safe, and scalable. So I'm a platform engineering ambassador and team topologies advocate, and that platform engineering background is actually very relevant to this topic, because when we talk about governance, I don't see it as a separate, it's just an only security topic, but I see it as a platform design topic actually. So good governance should not feel like a wall that blocks everyone. It should feel like a good set of well-designed guardrails that help teams, pipelines, automations, and these days, agents to operate safely without needing to remember every rule, every organizational rule manually. I promise that this talk is not going to be about AI at any shape or format, but especially the last 2 years, a lot of my work is around building AI platforms, like Gen AI platforms. And based on my experience, when we talk about this Kubernetes governance, we usually talk about developers, platform teams, CI/CD pipelines, and GitOps controllers, they are creating and changing resources, but now we are also seeing another actor entering the system, AI agents. So because you all maybe experienced that agents are not only, just answering the questions, but they take actions in our systems, whether update the configuration, creating objects in our Kubernetes clusters, so that the questions becomes kind of similar, is this action safe? Is this action compliant? Does it follow our naming convention standards, or include right labels, and etc.? So this is where, again, the policy engines becomes really interesting, really hot topic again. So today, Koray and I will talk about Kyverno and Cell as a way to talk about Kubernetes governance that can scale across teams, clusters, environments, but also keeping all these new agents concept in the back as well. So, long introduction. So sorry for that, but let's start. Most of the Kubernetes governance journey starts very innocently, right? Someone says, decides that we need a couple of policies, and those policies usually very reasonable reasons, we want required labels on deployments because we need ownership and cost tracking. We want we want to block image tags, latest image tag, because we need reproducibility, and don't ever use latest tag, right? That's never a good idea. We want to enforce resource request and limits, because we don't want noisy neighbors and heavy resource problems, and definitely we want to restrict the privileged containers. Because we care about security, and at this point, life is good. Maybe we have one cluster one team, a few policies, and everyone understands, everyone can follow what is going on. And this is usually the point where policy as code feels very simple, very clean, very useful. But of course, we know that platforms don't stay like this for a long time. Platform starts to grow. And suddenly we don't have not just one cluster anymore, we have multiple clusters. We have, we have development environments, staging environments, production, maybe like customer specific different environments. And those few policies become 60 policies or like more files. And this is where the governance starts becoming a bit painful for us. So what we start doing is that we start copy-pasting YAML everywhere. We create policies that are almost identical, but not exactly the same. Like one team needs a small exception, so we fork that policy and kind of tailor for them. Another environment has a slightly different rule, so we need another copy. So these copies start to drift. And then a simple change, like let's say we now decide to have a different label, suddenly you need to have 15 update on 15 different files, 15 different pull requests. So this is the point where governance becomes really hard to scale. And if you also think about the agents or any new actors come into the picture, this has become a bit more and more important. So any new joiners or these new agents, they may not know the production namespace requires specific labels. People may not know about the, some registries that only allow for specific teams or maybe different high availability rules depending on the environment. So if we really, really want everybody to operate safely, we need the platform itself to encode these rules, not inside a wiki page, not inside a prompt or someone else's memory. These things need to be in the governance layer in an easy way. So this is the shift that we want to talk about, right? So how do we shift from these static rules that looks almost identical but with slight drifts, but more into the dynamic guardrails concept? So static rules are easy to read, good at the beginning, but when every team, different namespaces, different clusters or environment needs slightly different versions, things start duplicate, as we said. So dynamic guardrails allow us to write the policies once, but make it behave differently depending on the context. So for example, a rule may be strict in production, but maybe relaxed in the in the development environment. A rule may depend on namespace labels, team ownership, environment type, or a rule may actually use an external configuration. So the policy logic can stay stable, stay the same, and data behind these policies can change. And that is especially useful things like some exception lists, team-specific thresholds, or resource limits, etc. So there's another thing about these dynamic guardrails that are important is the expressiveness of things. So sometimes the rule that we want to have is not that simple. Maybe sometimes we want to say that if a deployment has more than one replica, then it must have pod affinity. Or if this workload is in production namespace, then every container needs to have non-latest image tag. So there could be some conditions as well. And they are not exactly static YAML patterns, they are conditionals, they are context-aware rules. And this is where one of my favorite languages actually becomes very, very useful with Kyverno. It is CEL. So CEL stands for Common Expression Language, right? So you can think of it as a very lightweight expression language that lets us write these kind of conditions against Kubernetes resources. It's not actually a full programming language, but it's a good thing. It is designed to be, safe, fast, suitable for this policy style logic. So on this slide, we have a couple of examples. So we can do this basic Boolean checks, replicas greater than one. And we can do string operations, checking if a name starts with prod, has a prod prefix. We can work with lists. And we can safely access optional fields. So this is my favorite part about this, right? So because not every Kubernetes the Kubernetes resources are quite flexible, right? Not every field is exist in every object. So Cell gives us a very practical way to express rules, such as like, if this fields exist, check this. If this does not exist, use this default value. If this condition is true, I don't know, like require something else. So that makes policies much easier to write, easier to read, and maintain. So for today's talk, the important idea is that this Cell helps us move from this like matching YAML shapes that like very restrictive to expressing most like governance intent. So we start simple, and as the platform gets, as it scales, things get complicated, and when more and more automations and like agent type things also like get into the picture, policy becomes even more important, and it's important to have enforcing such boundaries. So right now, what Koray is going to walk us about, like this Kyverno's policy model, and then we're going to see actually how these things in action. So.
Yeah, thank you, Cansu. So, how many of you are using Kyverno in production? I would say less than half. Okay. So, how many of you have migrated your old policies to Cell already, or using Cell now? One. Okay, nice. So for Kyverno, we used to have two policy types, or a bit more, like cluster policy, and cluster cleanup policy. With the introduction of Cell to Kyverno, Cell is also supported by Kubernetes since version 1.25, I think, with validating admission policy, and Kyverno also started using it. So in version 1.15, the feature state was alpha. So you could start testing things out. 1.16, it became beta, and with 1.17, it is now GA, generally available. So it is stable now on Kyverno side. And so out of two policy types, they created multiple ones. So validating policy, image validating policy, mutating policy, and generating policy, as well as deleting policy for the cleanup. And they also said that these old ones are now deprecated, and they will be removed. I mean, if they continue with the plan, they will be removed around October with the 1.20 release. So we are now at 1.18. I think it was released a few weeks ago. And they only provide critical fixes for the old policy types. So if you're using them, you need to migrate sometime soon. So be aware of those. How does it look like? Like, this is an example validating policy where you can define some, does it work? No, it doesn't work. You can create some variables. This did not exist in the past, I would say, in that sense, not in dynamic sense. And you can query stuff, query some objects inside your cluster. And then you can run the validations with the Cell expression, like, if this has this, or and greater than or less than, those kind of all operations work there. I first want to show a live demo, how things work. I think this makes stuff a bit easier for you. Then I will explain them in more detail. So I have a kind cluster running here, and I'd like to create some namespaces and label them as well. Today I will show three types of patterns. One is like namespace-driven context, where you can make some decisions based on the namespace labels or annotations or whatever there. Then I will show the second pattern as externalized configuration, and the third pattern will be about the expressive invariance. So as you saw, I've already created some namespaces and labeled them, and of course not. I have a policy now checking for the namespace tier. So the variable, so I create a variable namespace tier and check the labels of the namespace object and check for the env variable. If it doesn't exist, I just put development there. So that's the part with cell being safe. Even you cannot get a value instead of null or something, you just can insert some default values there. And then the expression is like, if the namespace is production, so if it is not production, we don't care. Or if it is production, then all the containers must not end with latest. So we simply don't allow the latest image tag. That's the whole point. Let's create this one. It is created, and then if I create it in the prod environment, the prod has this env label describe ns. So env is production. Since production says that, hey, we need a specific tag there, it can't be latest. But if I want to try it on the dev environment, it will work because at the beginning we said we used or here, so since it is not production, it will just work. But then if you just provide, so for production you have to provide a valid tag. With the tag, it just works. So that's one thing that you can do based on the namespaces. So we did not create the policy based on deployments or daemon sets or pods. So whatever you, I mean, this one checks for deployments, but for all the deployments in this namespace and all namespaces. So whenever you create a new namespace with the labels, correct labels, let's say, it will work for all of them. So the second part is, I think this is the coolest one for Cell and Kyverno. You can query and get information from the objects inside your cluster. So here, I will first create a config map and I will define the allowed registries here. I just say that gcr.io/my.org and docker.io, my company, these are only allowed registries. You can create a config map, but it can be a secret, it can be a CRD that you create in whatever sense. Let me first create it because I then forget to create those. Then I have a policy for the registry. Sorry. No, but yeah, okay. So first, we use this resource.get. So this is, as Cansu mentioned, Cell is extendable. So this is a library extension by Kyverno to query stuff inside your cluster. So we query the config maps in Kyverno namespace named registry policy config and get the data of allowed registries, and then we split it, then have a list. And then we check all the containers if they start with the registry. So we go for all containers inside our deployment. It could be, multi-container stuff, and then we check for all allowed registries, and if it's not there, then we don't allow it. So let's try to create an application. So this random repo is not allowed because it's not in the registry, and allowed values are also here. So with also cell, your message is also like gets the data and replies back. So the configuration is dynamic, and also the error messages will be dynamic and based on what is actually needed for the application. But if I try to deploy it for gcrio.my.org, it will be allowed, and it is it will just work. So I just need to update the configuration, and here I will add gcrio. Let's say another one. And if I try to create this, this will also just work. So there are also some important points here. As you see, whenever this policy is run, it goes to Kubernetes API, reads the config map, goes through it, and then make the decision based on it. There are some tricks that you can do, I think, for caching and stuff to make things work. But having a lot of config maps, having a lot of policies like this would also put much pressure on the Kubernetes API as well. So there are good things, but I mean, you need to balance those kind of policies. You should not have all types of policies like this and query Kubernetes API all the time. So that was the second, I think this is the most important part. So for example, in other demos, I provided an example like to check all the ingress hosts inside the cluster, and if the new incoming ingress hosts exist already, then do not allow it. So you only want to have, so you want to have ingress hosts to be unique inside your cluster, then you can also do such stuff. And for the expressive ones, so just also talked about this a little bit. What I want to have is that for a deployment, if the number of replicas is 1, it's fine, just deploy it. But if it is greater than 1, then it has to have an affinity and pod anti-affinity. So we want to spread the pods to different nodes. That is, I think, important for especially for production. Of course, you can add more stuff here if the environment is production, blah blah blah. That sort of stuff. But then, if I try to create a deployment without affinity, so it just say that 3 replicas, but no pod anti-affinity, I will not allow it. We can just create an HA deployment. This is allowed, that's great. And we can also create a single replica deployment, which is also allowed, because if the single replica, it's fine, we will allow it. So with those 3 patterns, you can have more scalable environment and more dynamic policies, and especially with the second one, with having the configuration in a config map or secret, what you can do is that the policies can be created by the, let's say, the security team, and they can manage it, so they can decide what to do, and as the platform engineer, you can decide on the values. So you can say, yeah, this production or this team can have 5 replicas, the other can have maximum 3, etc. Or team X is allowed to use Docker registry, but the others are only allowed to use internal registry, etc. So you can do such stuff with Cell. So it brought quite some flexibility to Kyverno. Again, you can do namespace aware image tags or other stuff based on the namespace it's created. It can be config map driven, but actually it's any object driven, like a register allow list and other stuff. Or you can combine different situations, like if the replica count is greater than 1, yeah, I have to have pod anti-affinity or anything else. I think I believe I've already covered those, but again, the good part is that, or the important part is that with those settings, the policies and the configuration, configuration meaning that the data or the actually rule can live separately and not based on each other. Yeah, like for expressive invariance, you can also have, you can also use this one with limits and requests, or like the image has to match those kind of things, etc. Those kind of some like what's called the semantic versioning matches as well. So the idea is that with the old stuff, with the YAML only old policy types, the more environments, the more namespaces, the more teams you have, you would have more files. But with Kyverno and Cell, you would have less policy files, but they can be parameterized. And adding a new environment would only mean only updating or adding a new config map, not updating the whole policy file for the whole big YAML. And new, like onboarding a new team, like creating a new namespace for a team, would require less PRs, less data to update, and obviously the readability is way better than the old one, because with the whole I don't know if you had any, but the YAML files were like sometimes becoming huge if you have a lot of rules inside it. But with Cell, with those functions, it's more readable and easy to manage, I think, that perspective. So to get started, if you haven't used any policies or like trying out things, so I think it's good to label your namespaces with some governance metadata, especially if the applications for your teams and everything, or like multi-tenancy is living per namespace things. I think you should definitely label them and use those labels for your policies. Well, in any case, you'll have to move to Cell. You'll have to migrate to Cell. But to start with, I think it's better to start with some noisy policies and rewrite them with Cell. If you are starting new, just start with Cell directly. Do not use all those deprecated ones. You can run in audit mode first, so you can get the reports, but nothing will be, so everything will still working. So all the deployments will be created, but you will get some reports saying that, yeah, I've created this deployment, I allowed it, but it doesn't match with the rule, or it's against this rule, so be aware. That sort of stuff. And then, of course, iteration, that's the whole DevOps thing, platform engineering thing. You have to iterate and make things better. And I think Kyverno and Cell makes the policy as code thing, it's more scalable, more easier to maintain for all the platform teams. Well, thank you very much being here for all this time and towards the end of the whole event. That's it from our side. Huh?
Thanks for having us.
I don't know if you have time for questions or...